Welcome to Transmathematica School. I'm James Anderson. We already know what real and strictly transreal numbers are, but how do we put them together to make transreal numbers? That is what we'll think about today. Integral numbers are known as integers, real numbers are known as reals, transreal numbers are known as transreals. The shorter forms fit on the slides better. A fracterm is made up of a numerator and a denominator. A fracterm is a syntactic object. It's something you can write on paper. The numerator could be the Mona Lisa, the denominator could be the complete works of Shakespeare. If the numerator and denominator are integers, and the denominator is non-zero, then the fracterm is a fraction. Here's a dichotomy of fracterms that are fractions. Numerator over denominator with denominator non-zero. And fracterms that are not fractions, numerator over 0. If the numerator and denominator are reals and the denominator is non-zero, then the fracterm is a real number. For example, pi over 1, 3 over minus root 2, 0 over d with d non-zero. Here is a dichotomy of fracterms that are reals, numerator over denominator with denominator non-zero, and fracterms that are not reals, numerator over 0. If the numerator and denominator are reals and the denominator is non-negative, then the fracterm is a transreal number. Examples are pi over 1, minus 1 over root 2, 3e over pi root 2, 0 over d with d non-negative. Here's a dichotomy of fracterms that are transreals, numerator over denominator with denominator non-negative, and fracterms that are not transreals, numerator over denominator with denominator negative. It seems like we haven't made an improvement, but we've got ourselves into a brilliant position. We can now make a monocotomy of fracterms that are transreals. If we have a negative denominator, we can make it positive by subtracting top and bottom, by multiplying top and bottom by -1, or just by moving the minus sign. This last case occurs in programming. It's toggling the sign bit. If you're doing transmathematics on paper, subtracting top and bottom is the least amount of work. You don't have to write so much. If you're doing geometry, you'll probably want to multiply top and bottom by -1. Take your pick. Do whatever's the easiest. Transreal numbers are fracterms with a real numerator and a non-negative real denominator. This is a monocotomy of all fracterms of reals. Every fracterm of real numbers is a transreal number, and there are no exceptions. I hope you have enjoyed this video. If you want to learn how to divide by 0, do the following exercises. I'll put the answers at the end of the next video. The last question is ridiculously hard. Where possible, convert these fracterms to transreals. Wonder Woman over Superman, 0 over 0, -3 over 2, 3 over -2, 1 over 0, -1 over 0, 3 over 0, -3 over 0, 1 over -0, -1 over -0, 2 minus 2 over 4 minus 4, 0 times 2 over 0 times 4, 2 over 3 over 4. Here are the answers to the video tetrachotomy, the wildcard of transreal numbers. There is a link to the video in the description below. Go back to the video and write your score in the comments. If you get full marks, I'll give you a gold star. Well, it won't be real gold, and it won't be a real star. More of an emoji. And watch the video again. It will be good revision. So the question was, say whether the following are less than 0, equal to 0, greater than 0, or nullity. And the answers are 9 3/4 is greater than 0, 0 is equal to 0, -6 is less than 0, 0 over 0 is equal to nullity, 3 minus 2 equals 1, which is greater than 0, 2 minus 2 equals 0, which is equal to 0, 2 minus 3 equals -1, which is less than 0. Infinity is greater than 0. That was a trick question. I haven't actually told you enough in the school videos so far to know that infinity is greater than 0. You probably guessed it. Infinity doesn't have a sign and minus infinity does. You could have worked it out from the axioms of transreal arithmetic. Infinity is greater than 0 is axiom 9. Now, minus nullity equals nullity is a really hard question. You could have worked it out from tetrachotomy. The minus sign converts positive numbers into negative numbers and negative numbers into positive numbers. All other numbers it leaves the same. Nullity isn't positive and isn't negative, so it gets left the same by the minus sign. So minus nullity equals nullity. You could have worked it out from axiom 23 by setting a equal to 1. Check the description below for links to more material, leave questions in the comments, tell your friends and enemies about Transmathematica, subscribe if you still haven't, and if you want to support the advancement of science, see the About tab for donations. Bye for now.